So today we're going to do section 4.8, and we are going to barely start just to touch on a couple of things in 7.5 and then wrap up 7.5 on Friday. Okay, so in 4.8, the first thing I want to go over is 3 phrases or words that are interchangeable. Remember on Monday when we were talking about when we were solving quadratic equations and we were coming up with those 2 answers, whether we did it by factoring or we did it by the quadratic formula or we punched it into our quad program in our calculator to get our 2 solutions. So that's what we were calling them. We were calling them solutions. They were answers to solving the x squared equation. Well, another way that it called it was finding the zeros. Now we're going to see what that looks like on the graph. These two words can also be referred to as the x-intercepts of the parabola. So when we are looking at number 1, I'm going to solve it first of all using the quad program to show you how these things are interchangeable. So it tells me the function is x squared minus 2x minus 15 equals 0. So I could solve that by factoring. I could solve it by the quadratic formula. Let's just go and use our quad program. Remember, if you don't have it, it's going to be very, very beneficial for you to get this on your calculator. So if you need to schedule an appointment with me, or you can take it to the lab in the campus center building in room 310, and they can sync your calculator and give you the quad program. And they're there all day. So you can do that anytime. So this x squared minus 2x minus 15. I'm going to put this in my quad program. So program down to quad. So there's my quad program. Now remember, it's going to ask me, enter again, what my A is. Remember, what is A? A is the number in front of x squared. Since I don't see it, remember that represents a 1 right there. There is 1x squared. So my A is 1, so tell it 1. The B is the number in front of x, which in this case is negative 2. And the C is the constant, which in this case, the constant of this is negative 15. So there's your A, B, and C. Hit enter. So that right there are the solutions to this quadratic equation, 5 and negative 3. So let's look at what this looks like on the graph. And it actually gives you the picture of it. Look real close on that graph and look at its x-intercepts. Here's my x-axis right here. Look where it crosses it. There's one of the x-intercepts. And there's the other x-intercept. That's where it crosses through the x-axis. Look where it crosses. I'm going to hand draw this up here. So again, if you're looking at the one on paper, I just recreated this on the board with these 2 important points. Look where it crosses. It crosses the x-axis at negative 3 there, and it crosses it at positive 5 here. That's the solutions, the zeros, the x-intercepts, all the same thing, right? Negative 3 and 5 is what I got as the answers in my calculator also. So the first thing it's going to ask you here is what are the x-intercepts? So be careful when you type this in. x-intercepts there's two of them, right? This point and this point are the x-intercepts. If you are a point, which those are, you've got an x-coordinate and a y-coordinate. So when you're naming the x-intercepts, make sure you write it as an ordered pair instead of just numbers. So this first x-intercept, this one right here, is at -3. The y-coordinate at your x-intercepts is always 0. So -3, 0 is that x-intercept. This x-intercept is at +5, 0. So the first thing it's going to ask you is, what are the x-intercepts? So the x-intercepts are, you type in those two ordered pairs. The second thing it asks you is, these solutions are x equals blank. The solutions are not points. They are just the answer to the problem. What you got when you typed in 1, -2, and -15 into your quad program. What did you get? Your solutions are -3, and 5. You do not put parentheses around that. You are not naming a point there. That is not an ordered pair. So if you put some parentheses around this, you are telling that the answer is the point -3, 5, which it is not. The two separate solutions are -3 and 5 with no parenthesis around them. All right. Number 2 is the same kind of problem. I'll solve it with the quad program, and then I'll recreate the graph again just to drive home the point that the solutions to the quad program are the same spots where the parabola crosses the x-axis. So this time, I have 5 plus 4x minus x squared equals 0. So let's find the solutions using the quad program. Be careful here. Remember, when you're using the quad program, it's going to ask you what your A, B, and C are. This is written out of order. So remember, it doesn't matter where x squared is. A is the number in front of it. So this time, what is in front of this x squared? -1. So your A is -1. Your B is the number in front of the x, which will be +4. And your C is your constant, which is the number that doesn't have a letter with it, which is 5. So make sure you type in your A, B, and C correctly. So again, let's go to your quad program. So my A is -1, B is 4, and C is 5. So -1, 4, and 5. And hit enter. There are your solutions. -1 and 5 are your solutions. Those are the answers. Which means if I drew out this graph, where should the parabola cross through the x-axis? Well, at those two different spots on the x. So let's see what the graph looks like. And they drew the graph out there for you. So I'm just recreating this graph now. Look where it crosses. It crosses at -1 and 5. This time, this parabola is upside down. Remember what makes graphs flip upside down. Look what's in front of the x squared. That negative. Negative x squareds flip upside down. Remember in the transformation section where we were talking about things that shifted left and right and up and down, and then what flips graphs upside down? Well, if the x squared is negative, that's what made that one go upside down. Look where it crossed. It crossed at these 2 points, -1 and 5. But if you're naming the x-intercepts, that's when you are naming specific points. So that's when you're going to have the ordered pairs. So this first x-intercept, it doesn't matter which order you list them in, would be at -1, 0. And the other x-intercept would be at 5, 0. So that's how they translate into each other. Plugging it into the quad program and getting my answers is actually telling me where that parabola crosses through the x-axis. It is its x-intercepts. Okay? Now, problems 3 and 4 are dealing with what are called right triangles. So let's review a little bit about some information that it's going to assume that you already know about right triangles. Right triangles are triangles that have a right angle. So a 90-degree angle right there. So that's what we're going to be dealing with on these problems. What I know about right triangles is that they go along with the Pythagorean theorem. The Pythagorean theorem states that the length of the side, these two sides of your triangle, you square them and add them together. The way you see it written is a squared plus b squared. That is going to be equal to this side, which is called the hypotenuse, the long slanted side, c squared. So a squared plus b squared is equal to c squared, with these two sides being a and b, and then the long side being c. So it's just going to assume that you know that or you remember that, so I'm just refreshing that memory. So number 3 says, there is a wire stretched from the ground to the top of an antenna tower. So I've got an antenna tower, and then there's this wire that is stretched to the top of it, and then there's the ground. So it makes a right triangle. So again, here's my wire, and then this side right here is the antenna tower, and then there's the ground. So it makes a right triangle. So again, a wire is stretched from the ground to the top of an antenna tower. The wire is 35 feet long. So I know how long the wire is. It's 35 feet. The height of the tower. So here's the height of the tower. Even though it's not drawn to scale and it doesn't look like it, it says the height of the tower is 7 feet greater than the distance from the tower's base to the end of the wire. So in other words, it is saying that this side is 7 feet longer than this side. So I'm going to name this side x. If this side is 7 more than that, then this side will be x and add 7 to it. So the wire is 35 feet long. The height of the tower is 7 feet longer than the distance from the base of the tower to the wire. So now that we know what the Pythagorean theorem says is the length of this side, so what is this side here? This side is x plus 7. So the length of that side squared plus, what's the second part of the Pythagorean theorem? This side squared. So the b squared, so down here, how do you write this side squared? Well, it's x, so I'm just going to write it as x squared is equal to the slanted side, the hypotenuse squared. So this side will be 35 squared. Now we got some work to do. We're trying to find out what x is. Because if I know what x is, then I know what this distance is. And then I can find the height of the tower by just adding 7 to that distance. So let's solve this equation. It is an x squared equation, so I am going to use, I have my quad program, so if I can get this set up to go to my calculator and put it in my quad program, that's going to be nice. What does your quad program need to know? It needs to know the number in front of x squared, the number in front of x, and your constant. So what I've got to do is clean up this equation, get everything on one side, and set it equal to 0. Everything needs to be together on one side. So let's see how I'm going to make that happen. First of all, x plus 7 squared means x plus 7 times itself. So let's write that all the way out. Let's see, I'm going to have to FOIL this. X times x gives me x squared. My outer, x times 7 is 7x. My inner, 7 times x is another 7x. And then my last, 7 times 7 gives me plus 49. But look here. Those 7 x's that are together in the middle right there, I need to put that, they're like terms. So if I put those together, I really have 14x. So over here now, I've got x squared plus, put my 7 x's together to get 14x plus 49. So all I have done so far is the x plus 7 squared. I FOILed it, which gave me x squared plus 14x plus 49. Now, this x squared, I'm just dropping down, equals, on the right side, I've got 35 squared. So let's see what that is. 35 squared, oops. Gives me 1,225. So let's see, on the left, I've got this x squared and this x squared that I can put together, right? They're like terms on the same side. So I actually have 2x squared on the left side. So 2x squared plus 14x plus 49. So all I've done so far is put those x squareds together. Still equals to 1225. So I'm going to rewrite this over here just to get to where we are. So just rewriting this equation, 2x squared plus 14x plus 49 equals 1225. So just getting us up to speed, just rewriting it so I have a little more room underneath to work. Now, everything, remember, my whole goal is if I can get to the quad program and punch this in, I'm going to have my calculator solve this problem. It's just getting to that point. So now I need to have all of this set equal to 0. So this side needs to be 0. So now I need to subtract 1225 from both sides so that I'll have a 0 there. Because before you pick your A, B, and C to use in your quad program, everything has to be on one side. So subtracting 1225 from each side. So now I have 2x squared plus 14x. Then I have 49 minus 1225. So 49 minus 1225 gives me negative 1176. And that's equal to 0. So everything's on one side, set equal to 0, which means here's my A, my B, and my C that I can punch in your quad program. Now remember, when we're solving quadratic equations, we get 2 answers. So I'm going to have to look at my 2 answers and decide which one makes sense and which one doesn't. Because remember, I'm solving for this x is what I want to know. But it's going to give me 2 answers for x, right? Because it's an x squared equation. I'm always getting 2 answers. So let's see. Go to your quad program. So program down to quad. Enter. Let's see. My A, the number in front of x squared is 2. B is the number in front of x, which is 14. C is my constant, which is negative 117. Hang on. I think I subtracted that wrong. That's not 1177. It's 1176, isn't it? 49. Yeah, sorry. This right here, I subtracted that wrong. 49 minus 1225 is negative 1176. So that's your A, B, and C. 2, 14, and negative 1176. So let's see what that gives me. So when I put those numbers in for A, B, and C in my quad formula, it tells me 21 and negative 28. Let's think about this. Which one do you think makes sense? What is X representing? It is representing the distance from the base of this tower to the end of the wire. Look at your 2 options. It's either positive 21 or negative 28. Well, if I'm talking about the distance of something, does a negative answer make sense? It doesn't. You're not going to be a negative amount of distance from something. This is not going to be represented by a negative number, is it? No. It's a distance, it's an amount of feet. You're not negative 28 feet, which means your negative 28 doesn't make sense. So 21 is your solution for X. So X is the distance from the base of the tower to the bottom of the wire. So that's going to be 21. Now, this is not a coincidence. The height of the tower, look what it is. X plus 7. So 21 plus 7, which is 28, which is actually just the positive of what that other number was. That is not a coincidence. That's what's happening on that problem. So 21 and 28. All right, number 4 is dealing with the same kind of problem. It actually ends up not being near as difficult though, because of the information that they give us. So still going along with that Pythagorean theorem. So this one says the foot of an extension ladder, so we've got an extension ladder, is 7 feet from a wall. So here's the wall. Here's the ladder. And there's the distance from, so here's your ladder. Here's your wall. So from the base of the wall to the bottom of the ladder is 7 feet. So it tells you that side right there is 7. Now, the second part tells you the height that the ladder reaches on the wall. So this height right here. This is the height that the ladder reaches on the wall. So this distance right here. And the length of the ladder. Well, here's the length of the ladder, right? That's what represents your ladder, is that slanted line, right? That's what your ladder looks like going up against the wall. Is consecutive integers with this distance. So it says the height of the ladder reaches on the wall and the length of the ladder are consecutive integers. What that means is this number comes right after this number. Consecutive integers are numbers that come right after each other. It's like you're counting. Consecutive integers will be 6, then 7, then 8, then 9. Those are consecutive integers. So if this distance to this distance are consecutive integers, this is going to be x. Well, if this is right after that, it's going to be x plus 1. Now, let's see, why am I saying this one's going to end up better than the last problem? Let's set this up with the Pythagorean theorem. A squared, which side represents your A over here? This one. So square it, which just gives me x squared, plus this side squared. So what represents your B on this triangle? The 7 squared equals your C side, which is this one right here, squared. So x plus 1 squared. Let's write this out. Let's see. X squared plus 7 squared is 49. Equals, let's see, I'm going to FOIL that over to the side. X plus 1 squared means what? If I'm going to square this, that means to multiply. X plus 1 times itself. So let's FOIL that over to the side, and then I'll just write it right here. So let's see, if I FOIL that, x times x gives me x squared. My outer, x times 1 gives me 1x. My inner, 1 times 1 gives me another 1x. And then my last, 1 times 1 gives me 1. Just like the last problem, the middle two terms are like terms, and if I put 1x and 1x together, I get 2x. So I'm left with x squared, put those together to get plus 2x plus 1. x plus 1 squared that I worked out all up here ended up being x squared plus 2x plus 1. So let's write that here. So remember on the last one, so right now it's looking like an x squared equation. But look what happens. Remember on x squared equations, you have to have everything on one side. So I'm going to start off by moving this x squared over here, which means I would need to subtract x squared from both sides. But here's what happens. If I subtract that, so I canceled it there, which is what I was trying to do. But look what happens over here. It also cancels your x squared out over there because you had x squared minus x squared. So you have no x squareds left. So let's write out what we do have left. I've still got the 49 here. On the right side, all I have is 2x plus 1. Remember, I need to know what x is. Well, now I'm just solving for a plain x. There is no x squared. I don't need my quad program because it's not a quad equation anymore. It's just a plain linear equation that I want to solve for x. So if I'm getting x by itself, I need to subtract 1. So on the left, I've got 48 equals, on the right, I've got 2x. So to get x by itself, all I need to do is divide both sides by 2. So when I divide both sides by 2, what does it tell me x is? Let's see, there's my x. What's 48 over 2? It is 24. So that's what x is. I just solved for x. It gave me 24. Now, be careful on this problem. The only question that it asks you, the length of the ladder is blank. Well, here's the length of the ladder. This is the side that represents the ladder, which is the number right after 24, right? Its consecutive integer would be the number right after 24, or x plus 1, which is 25. So the length of the ladder is 25 feet. All right, so that was 4.8. We're going to work the first 2 problems in 7.5 just to get us started, and then we'll wrap up 7.5 on Friday. Okay, 7.5, we're going to be analyzing quadratic functions, which are parabola shaped, or the x squareds. The first thing we're going to talk about is the vertex of these shapes. So remember, all x squared graphs make this shape. It may be upside down, but it is the same shape. It's a U shape. Some are wider, some are more narrow, but they're all U's. There is a point on the U, for instance, on this one. It stops coming down right here and then changes and starts going up. This one goes up until it gets to this point, and then it goes down. That point, whether it's on either one of those parabolas, is called the vertex. So So the vertex is the point of the parabola where it stops going one direction and flips and starts going the other. So if I was going to make this vertex, if this parabola symmetrical, remember how we talked about symmetry earlier in one of the sections, where one side of the graph exactly looked like the other? Wouldn't the line that makes these parabolas symmetrical it would have to go straight through that vertex, right? That would make one side mirror the other, whether or not it's upside down or right side up. That line goes straight through the vertex, and then either side of the parabola matches the other. So we're going to talk about those two things. One more thing. So this would be its line of symmetry. We're going to call it an axis of symmetry. Is the line that cuts it in half. This is its axis of symmetry. Now, sometimes a parabola has a minimum value, which would be the very lowest point of the parabola, and sometimes it has a maximum value, which would be the very highest point of a parabola. And it all has to deal with, is my parabola open like this, or is it upside down like this? So if it's open like this, this point right here is isn't at the very lowest point of this parabola. Everything else is above it. So if the vertex is down here, it's the minimum of that parabola. Look at this vertex. It's at the very top of the parabola, right? The highest point, which means if that's where the vertex is, then it's the maximum value of that parabola. So again, the vertex either represents the minimum value or the maximum value. And if I drew a vertical line straight through that vertex, it's going to cut the parabola right in half and make either side symmetrical. Okay, so let's use all this information and we're going to do numbers 1 and 2. All right, number 1 gives us a graph. Looks like that. Again, I'm just reproducing the graph of number 1. Look what it says that point is. It's naming the vertex right there. It's telling you what it is. It's saying the vertex is at -3, 4. So this point right here, it's saying is at -3, 4. Which is the exact first question that it's going to ask you. Where is the vertex? The vertex is -3, 4. Again, the vertex is an actual point, which means it goes in an ordered pair, right? All points come in the form of ordered pairs. So -3, 4. Now, the second thing it's going to ask you is, where would the axis of symmetry of that parabola be? So the axis of symmetry, remember what we talked about, what it is. It is this vertical line that goes straight through the vertex, right? That's the line that cuts through this parabola and makes one side symmetrical with the other. So it wants us to name the equation of that line. So it tells us that it wants us to write an equation, not just a number. Well, if I know this right here, it's a vertical line, and all vertical lines come in the form x equals, and then whatever, look at every single point on this x. Where have you gone? Doesn't matter where you are. What would your x coordinate be no matter where you are on this line? No matter where you are, haven't you gone to the left 3? If I've come over to the left 3, that means my x coordinate is -3. So again, if you know the vertex, the axis of symmetry is x equals whatever the x coordinate of the vertex is. So that's the axis of symmetry. Again, it's going to ask you the axis of symmetry, and it's going to even remind you, type an equation. X equals whatever the x coordinate of that vertex was. Now, the very last thing it's going to ask you is, what is the minimum or maximum value of the function? So when it's talking about value, it's talking about the highest or lowest point. Well, since this parabola comes down to here and goes back up, this is the vertex is its minimum, right? It's the very lowest point of that parabola. So this one has a minimum, not a maximum. Remember, maximums would be if the vertex was at the top, because your parabola is upside down. So this right here, here's the point. It is always just whatever your y value is. When you're talking about value, you're talking about the y coordinate. So its y value or its minimum is at 4, not y equals 4. We're not talking about a line with an equation. We are just talking about a number value. So the number value of this one is 4. That's its lowest value. Okay, let's do number 2, and then we'll be done. We'll wrap this up on Friday. Now, look at the difference between number 1 and number 2. Number 1 gives you the vertex. It draws the U shape and gives you the vertex. Number 2 doesn't draw it. It just gives you this part. So let's see. I've got x squared minus 12x plus 35. We're going to do it algebraically today, and then on Friday I'm going to show you different ways to do this in your calculator. So the first thing it's asking me is, where's the vertex of this parabola? Which means, where is the point where it changes direction? The way you find it algebraically is by using the opposite of b over 2a will give you the x coordinate of the vertex. So remember, I'm going to have a parabola. It's going to have a vertex. I am finding the x coordinate. Remember, it's a vertex, which means it has an x coordinate and a y coordinate. This is how you find the x coordinate. And this right here doesn't just come out of nowhere. Remember the Pythagorean theorem, the quadratic formula? Look at outside of the radical. That's where it comes from. The opposite of b over 2a comes from this whole entire quadratic formula has everything to do with parabolas and x squared equations. This part of it, the opposite of b over 2a, is going to tell me what the x coordinate of this vertex would be. So remember where your a, b, and c are. A is the number in front of x squared, b is the number in front of x, and c is your constant. So let's see. Here's my b, but I need the opposite of it. So the opposite of this b would be positive 12. What's the bottom going to need to be? 2 times a, which is 2 times, what is representing a? Since I don't see it, it's a 1. So now I have 12 over 2 times 1 is 2. And 12 over 2 gives me 6. So now I know the x coordinate of the vertex is 6. How am I going to get the y? Well, now that I know what x is, remember, f of x is the same thing as saying y. So this really says y equals whatever x squared minus 12x plus 35 is. Well, now I know what x is. I know x is 6, which means I can replace those x's with 6's and solve it for that y. So let's replace the x's in the function with 6's. So I have 6 squared minus 12 times 6 plus 35. 6 squared is 36 minus 12 times 6 is 72 plus 35. So if I add and subtract straight across, I get negative 1. There's your y. Negative 1. So there's your vertex. Your parabola is going to have that shape, have its vertex at 6, negative 1, which would be to the right 6 and then down 1. So your vertex of that parabola will be right there, right 6 and down 1. Now that I know the vertex, I can get a lot of information from that without even seeing the graph. So now it says find the equation of the axis of symmetry. So we'll just say that this is what the parabola looks like. This is the point 6, negative 1. Remember, the axis of symmetry will be the vertical line that cuts it right in half, and it's always x equals whatever that x coordinate was. So there's your axis of symmetry. The next part of the question says, determine whether the parabola has a maximum or a minimum. Now, remember, I haven't graphed this, but this right here, what would make this turn upside down? Because that's what's going to tell whether the vertex is a maximum or minimum, is whether or not the view is right side up or if it's upside down. This one would be a minimum. But if this 6, negative 1 happened to be this point right here, it would be a maximum. If you want to, you can just go straight to your y equals and type that in. See which way, graph it. Go ahead and graph it. See which way your parabola goes. So I'm at y equals, I'm going to type in x squared minus 12x plus 35. X squared minus 12x plus 35, and hit graph. That's not graph. Hit graph. So remember where the vertex was. To the right 6 and down 1 for 6, negative 1. That's the vertex that we've already figured out algebraically. Look, and it's at the bottom, right? Because it's at the bottom. It's not upside down U. It's a right side up U. So its vertex is at a minimum. So this one has a minimum value. And what is the lowest point? If this is at 6, negative 1, the lowest point is the y value, which is negative 1. So it has a minimum of negative 1. The way a parabola is upside down is if the x squared is negative. That's what turns it upside down. So since my x squared is not negative, that's what keeps it right side up. And we're going to learn much more about these starting on Friday and then a lot more throughout the semester. Okay, so that gets you through number 1 and number 2. So we will wrap up 7.5 on Friday. So see y'all Friday.